Welcome back for another deep dive. Today, we're exploring kind of a cool intersection.
Yeah, where math meets the real messy natural world.
Exactly. We're looking at how some concepts from calculus, differentiation and integration.
How they actually help us understand things like forest resources technology. It sounds abstract, but it's very practical.
Right, and our source material gives us a really specific focus for this. It's about integration in forest resources technology,
Hmm.
and specifically looking at calculating total seed dispersal over time. Seems like it's aimed right at college students learning this stuff.
Yeah, and what's really interesting there is how it uses integration, this mathematical tool,
Right.
to get a handle on something very concrete.
Hmm.
How many seeds actually land over a certain time in a forest.
Which is super important for, like, regrowth,
Most
right?
definitely. For natural regeneration, understanding seed numbers is key.
So if you're maybe hitting the books right now, grappling with integration, thinking about seeds, actual seeds, landing in one spot over, say, a few months, that can make the whole idea feel a bit
Less
less.
theoretical.
Yeah, less theoretical, more tangible. You can sort of picture the math doing something.
That's a good way to put it. Because, you might use differentiation first.
Okay, how so?
Well, differentiation could help you figure out the rate, like how fast seeds are dropping from one tree right now.
Or maybe how densely they're landing, like more seeds close to the tree, fewer further away.
Exactly, that instantaneous picture, the how fast or how concentrated at this moment or at this specific spot.
Okay, so the source probably gives like a function for that, maybe an RT, for the rate over time, seeds per hour.
Or maybe a dxy for the density,
Mhm.
seeds per square meter across an area.
Right, right.
But see, the real problem for a forester isn't just that rate right now.
Okay.
They need the total. How many seeds fell from that tree all season? Or how many landed inside this specific plot they're studying?
Okay, so not the rate, but the accumulation.
Precisely.
Yeah.
And that's integration.
Right. Differentiation breaks it down to the rate.
And integration builds it back up. It sums up all those little moment-by-moment rates, or all those point-by-point densities.
Over the whole time period or across the whole area you care about?
Yeah. It's finding the area under the curve, if you plot that rate function, RT, or the volume under the surface for that density function, dxy.
Over whatever interval or region matters for the question.
And this is where, the source material makes it really practical. It shows why you're learning to calculate, say, the integral of RT dt.
From the start time to the end time.
Yeah, or the double integral of dxy dA
Yeah.
over some area. It's not just symbols on a page.
It's actually counting seeds, basically. Quantifying a biological process.
Exactly. So imagine foresters tracking regeneration after, I don't know, a fire or logging.
Okay.
They can't just pop out for 5 minutes and measure the seed fall rate. That tells them almost nothing about the long term.
They need the total accumulation over weeks or months to see if enough seeds actually arrived.
Right. Or maybe they're comparing different tree species. How far did their seeds travel? How many land in zone A versus zone B?